Hi guys, sorry I'm not here with you, but I am still here with you in spirit. Except I'm not. I'm probably in Florida somewhere. Anyways, we're going to be working on graphing simple rational functions today. So in order to graph them, it's pretty easy. We're going to use our graphing calculators a bit. So if you haven't grabbed one yet, make sure you do that, or use the Calculate 84 or Wabbit Mu on your sorry, I was opening a file. Use that Wabbit Mu or Calculate 84 app on your phone. So we are going to be needing that to be able to do our work today. So to graph a rational function, first of all, what do they look like? So here we have, there's this nice simple rational function. They kind of look like the inverse variation problems. And in fact, they are formats of the inverse variation problem. So the first thing is, we have, here's the equation for a rational function. It says f of x, or sometimes y, equals p of x divided by q of x. So what are those things? P of x and q of x, those are polynomials. Okay, so they just mean that this is going to be a number on top, either just a number, or it could be like 3x plus 2. It's a polynomial. Same thing down here. We could have just a number, or we could have a polynomial like 5x minus 7. I don't know. The graph, so what we see here, this curved graph, that is called a hyperbola, where it kind of splits. And the graph has two symmetrical parts. So you can see here, these do have symmetry if we were to reflect across. Those symmetrical parts are called branches. So we're going to be graphing the branches of a hyperbola today. So we have two different types of hyperbolas, or of rational functions that we're going to be graphing. And those two functions are, well, the first function looks like this. It looks, let's see if I can get my stuff to pull up here. My cat is trying to climb on my keyboard. So this first one kind of looks like this. We have y equals a x minus h, or divided by x minus h plus k. So we want to, I'm going to make a little note here. I had a favorite font that I was using earlier and it didn't save. Dang it. I can spell G-E-F-G, Georgia. That one's my favorite. And I'm going to put this in. So this is one type of rational function. Okay. There are many types there's another type that we're going to look at later, but this is just one of the types. And in this type of rational function, we have two things that are called asymptotes. They are basically going to keep us from graphing and connecting these two branches together. So an asymptote kind of defends this and makes them curve in one way or the other. So our first asymptote is called our vertical asymptote. That is a equation of a vertical line, and it comes from just x equals h. It just comes from the denominator of the fraction. Because a vertical asymptote, if the denominator was to become 0, then we would have this undefined vertical line. It would not work. You know, think slope, dude. What's the worst curse word in math and in algebra? Undefined. So that's where, so if x was equal to h, it'd be h minus h, and that would create 0, and that's an issue. So we can't have a vertical asymptote, or we have to have a vertical asymptote that kind of keeps us from reaching that value. The horizontal asymptote, well, here we have this equation. I don't know if you noticed, we've got h, a, and k. We're not actually going to be graphing them with shift, but it does have that same idea of how everything works. And k is just going to give us our horizontal asymptote. So that is basically what's keeping these two lines from coming together across the middle here. So a nice horizontal line. So in this case here, here's our equation that we have. We have y equals 1 over x minus 3 plus 2. So our vertical asymptote, if I was to look at this denominator, I have x minus 3. So really, it's just saying if I took x minus 3 and I set it equal to 0, I would get a vertical asymptote of x equals 3. Oops, that's not what I wanted. Where's my... Oh, I see. I got it. Okay, got it. So I have a vertical asymptote here of... Why is it doing that to me? It's being so rude. Okay. I want this there we go, x equals 3. It's because I was clicking on the line. So there would be my vertical asymptote. And if I drew that vertical asymptote into this equation, typically I draw them with dashed lines. I'm going to use purple for vertical, and I'm going to dash the line. And so that would be this vertical line, x equals 3. So there's our first vertical asymptote. And we can see that these lines, the branches, approach that vertical asymptote. Our horizontal asymptote is very similar. Our horizontal asymptote is just going to be taking this y value, this k, at the very end, saying that like if all of this disappeared, then we would have k. And so really we're just going to say our vertical asymptote is not that. Our vertical asymptote would just be y equals 2. Okay, so that's a horizontal line. That's the equation of a horizontal line. So if I was to go on ahead and graph this horizontal line, I'm going to use, again, a dashed line to show, and that's going to be my horizontal line, y equals 2. So then the question becomes, well, what's the domain? What is the domain? That's a great question. So our domain, remember, is our x values from left to right, so lowest to highest. So this graph is coming along, everything is starting way out there at negative infinity, it's moving along, and then it's like, whoop, we got to split. So, and then it picks up on the other side of that asymptote, and then it keeps on going. So when we go to identify our domain, it's doing it again. I don't know why. So when we go to identify our domain, I'm going to see this as, I'm going to do my negative infinity, and I got to put in my little infinity symbol here. I'm just going to kind of put this thing off to the side. I'm going to do negative infinity. And then I'm going to stop my asymptote, is going to actually stop my domain from reaching all the way straight over to positive infinity. So my asymptote is at 3. And I'm not going to close it in. I'm going to use a parenthesis, not a bracket, because I don't want this domain to include 3. Because if it was actually equal to 3, I'd have 3 minus 3, which would be 0, and then we'd have undefined. And we don't want that. So then I'm going to use this little U symbol that's saying that union. So we're saying this is the left and union, and then it picks up again on the right, starting at that positive 3, not including the 3, but just beyond the 3. And then we pick up and we continue on with positive infinity. You can put your positive there if you want. I like to do that, but you don't have to. So that I'm going to put back in purple here really quick. That would be our domain for this graph. So going up to approaching that asymptote and then continuing on the other side. Our range for this graph is kind of the same thing. We're going to go bottom to top, so we can see all the way down. It's going up, 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 kind of starts curving to the left, but it's still going up, 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 and then it approaches that asymptote and it stops. And it's like, whoa, folks. And so it's not going to continue on. But then right after that asymptote, we can see, oh, actually it's going to pick up again and it's going to keep on increasing. So we need to show how that asymptote works. And so we're going to go negative infinity again, insert, and now we're going to approach, and it's going to come up to, and it's going to kind of hug the line where y is 2. And then we're going to say, actually, it's not done there, because then it picks back up. So I'm going to insert that union symbol, and we're going to pick back up on the other side, the top side of the 2, and we're going to keep on going until we get to positive infinity. And that's how we write our domain and range. We use those asymptotes, those two numbers here kind of affect how our domain and range. The x asymptote, or the vertical asymptote, affects the domain. The horizontal asymptote affects the range. So here we have another one. I've got this nice graph, so we can see we've got the branches kind of flip around a little bit, because here the branches were in the first, or kind of looked like they were, you know, if this was the quadrants, it'd be like our first and third quadrant. And we had a positive 1 up front on top. And now we can see, oh, if we were to draw in our asymptotes, looks like I have an asymptote right about here, and I have another one right about here, it appears. So we can see that we've got, they've kind of switched. Now we're in the second and fourth quadrant, and that's because we have a negative up front. So that negative on top really just tells us that it's switching the areas where the branches lie. So again, just really quickly trying to run through this. If I was trying to find my vertical asymptote, I would look at the denominator. I would have x plus 4 equals 0. So if I wanted to type that in there, it would look like x plus 4 equals 0, which would then give me an equation of just x equals -4. And that, sure enough, is what my vertical asymptote will be. And that is an x equals -4. My horizontal asymptote, that's just the number at the end. That's just going to be my y. And my asymptote will just be y equals -3. And we can see that on the graph too here. Y equals -3, x equals -4. So then our domain. So if I'm looking at my domain, same thing from left to right. I'll go -infinity. And I'm going to pick up with my vertical asymptote. And then we're going to say on the other side of that vertical asymptote, so I'm saying from -infinity, hits that purple, and then it picks up on the other side and keeps on going to the right. So then we'll go from -4 to +infinity. Again, we don't actually put in brackets because we are not going to be including the value that is the asymptote. The asymptote is kind of like the cutoff point. So then same thing for our range from bottom to top. So just kind of remembering from bottom, the lowest this is going to get, it would be our -infinity. It would keep on going down. And then we're going to see we kind of get a split, and then it goes up to infinity. So it splits at that -3. So we have -infinity to -3. And then we're going to split. So we're going to say also on the other side, we're going to, oops, wrong one. That's the upside, that one. There we go, insert. And then we're going to pick up at that -3 on the other side, and we're going to go all the way to +infinity. And that's how we do that. So pretty easy, hopefully, just identifying those key components. And you can get all of those key components right off of the equation. So it makes it pretty easy. So then how do we actually graph one of these things? How do we get the branches to show up? And that's kind of a new little trick for us. So what we're going to do is we are going to graph. So here I have 3 over, my cat is like biting everything. Come on, cat. You guys can't see her yet, but so I have this new equation. I have 3 over x minus 1 plus 2. So we can pretty quickly here, looking at the equation, we could probably figure out what our asymptotes are. So that's the first thing. We got to find the asymptotes. And we're going to draw those on the graph. So if I look at this, I have a vertical asymptote that looks like it's going to be about, let's see here, do I have my dotted lines? Whew, I have it all already. So it looks like my vertical asymptote is going to be x equals 1. So I'm going to do a vertical asymptote at x equals 1 because this was x minus 1. So if I plugged in 1, 1 minus 1 gives me 0, and that's undefined and not going to work. My y asymptote, or my horizontal asymptote, that would come from the number at the end. That's just a 2. So right there, I've now already defined my vertical and horizontal asymptotes. And so I can look at that here, and I can say, once again, my vertical asymptote, oops, I don't know what I just did there. My vertical asymptote is x equals 1, and my horizontal asymptote was y equals 2. So nothing too terrible there. We also then are going to be able to tell what our domain and range are based on our vertical and horizontal asymptotes. I know that I'm going to put that in green so I color code a little bit. I know that my domain should be from -infinity. So we really can fill all of this out like right off the bat to +1. And then I'm going to join that with the other side, 1 to +infinity. I can do the same thing with my range, and I can pick that up. I can say my range is going to be, even though I don't even have this thing graphed yet, I know my range is going to be -infinity to 2. And then I'm going to join that up with, so I'm going to join it with, oops, the other side, 2 to positive infinity. So I can answer all of these big questions without even doing the graph. But the questions are also going to be, what does the graph look like? So how do I get this? So once I've drawn my asymptotes on the graph, I'm going to plot at least 2 points to the left and at least 2 points to the right of the vertical asymptote. So I want to go here and here. Now they're not going to ever be next to each other. They're going to be kind of opposite each other. So we're either going to be, if you think of these as quadrant sections, either the first and the third or the second and the fourth. Since this is a positive 3, it should be the first and third quadrants when I graph this. So I'm going to use my calculator now, and I'm going to try to graph this. So let's see if I got this all lined up right. There we go. So here's my calculator. I'm going to zoom in just a little bit and see if I can type this in. So I'm going to go, I got a bunch of stuff in here. I got to clear this out. I'm using my phone calculator because I didn't bring mine home with me. So I want to graph here once again. I want to graph 3 divided by x minus 1 plus 2. Let me see if I can make that. There we go. That's a little better. So I'm just going again, just so you guys can see, I went to my y equals button, and I'm going to do 3 divided by. Now I want to tell the calculator that x minus 1 is all part of the denominator, so I need to make sure I put in parentheses x minus 1. And then after that parenthesis, or after that denominator, I'll close the parenthesis, and then I'll do my plus 2. And so I'm going to hit zoom 6 just to make sure that everything, that I have a 10 to 10 section. And I can see here, there's my branches. It does not draw the asymptotes in for me, but I already know where they kind of are. So I know I'm going to try and sketch these 2 branches. And the easiest way to do that, just like how it kind of looks on here, is to look at a table of values. So if I want to get to my table, remember we're going to go ahead and push second and the graph button, and that's going to bring up my table. So we say you want to do at least 2 points. The more the merrier though. But as you can see, if I go all the way out to -10, I don't have too many points that are all that great to graph. I could do maybe -5 and 1.5. I've got -2 and 1. I've got -1 and 0.5. That's gross. I've got 0 and -1. Oops, let me scroll back down here. And of course here, when I see 1, I get an error because that's my asymptote. So what I'm going to go ahead and do, I'm going to do that -5, 1.5, the -2, 1, and the 0, -1. So it says at least 2 because it's going to give you a little more specific location for your graph. So -5, 1.5. So if I go ahead, I'm going to try to type these in here really quick. I'm going to do, oops, that's going to be too big of a font. Let me shrink my font down really quick. So on the left side of the graph, those are my negative numbers. So I have -2, and I'm going to plot 1.5. Oops. Yeah, 1.5. Then I had, no, that's not going to do it. I was hoping I could just hit enter and it would work. There we go. So then I have negative, let's see here, what else did I say? Oh, that was it, -5. There we go, 1.5. -2, and I was going to graph just the 1, and then I was going to graph 0, and I was going to graph -1 for that. So I said at least 2, the more the merrier. So, and then on the right side of the graph, I'm just going to come over here, and I'm going to plot some more points. So let's see some more points here. From the right side of the graph, anywhere, let's see here. So looks like I could do 2, 5 pretty easily. I could do 4, 3, and 7, 2.5. So I'm going to go ahead and over here, and I'm going to do 2, 5. Oops, 2, 5. And I'm going to do 2, 5. Let's see here. I'm going to do 4, 3. And I'm going to do 7 and 2.5. Okay, so I'm going to plot these points. Oh my gosh. My cat is climbing around on top of my cabinets, trying to make as much noise as possible. All right, so I have -5 and 1.5. So there's a point. I have -2, 1. I have 0, -1. And that's kind of what's going to give me that curve that I'm looking for. Here I can see I'm going to have 2, 5. Oops, 2, 5. I'm going to have 4, 3. And I'm going to have 7 and 2.5. So we can see they kind of have that same symmetry in the graph. This one's 1, 2, 3 away. This one's 1, 2, 3 away. This is 1 point away. This is 1 point away. This is a half point from that symmetry from the asymptote. Same thing here. So the last thing we do then is, I'm sure you probably guessed it, we connect the points to create these nice smooth branches. So of our hyperbola. So I'm going to do the best I can on this because I am doing this on a computer and it's not very easy, but we're going to just kind of eyeball this, try to connect our points together and make a nice hyperbola that sort of approaches but never actually crosses those asymptotes. So there we go. So there's our hyperbola. That's it. That's all you do to graph it. It's nothing too terrible. And we've already, because we identified our asymptotes, we've already kind of answered the main questions that have to do with it. So these are pretty easy. It's mostly just type it in your calculator to get the values, to get the points. And then from there, we can do the rest. So we have one other form though. So this was a form that was, let me go back here. This was one type of rational function where we had a over x minus h. And now we have we'll do another form that looks kind of like this. So here's our second form of a rational function. It looks like this. And this is going to be a little bit different. So with this second form of a rational function, to find our vertical asymptote, it's not just, x equals -d or anything like that. We just set the denominator equal to 0 and we solve it. So we'll just take whatever happens to be on the bottom and we set it equal to 0. To find our horizontal asymptote, so our y equals, we divide a and c. So in this graph, if I was looking at this, I'm going to do a divided by c. So the x part divided by the x part, basically. So that's the goal. That's the goal with finding our horizontal asymptote. So they look a little bit different. Here I have a graph of this example right here, this 4x minus 3 over 8x plus 24. So to find our vertical asymptote, we're going to take that denominator part, that 8x plus 24. We're going to take that and set it equal to 0. So if I was to solve this or want to try and solve this, I'm going to have to do 8x plus 24 equals 0. And so if I was to go through and be working on my solving my t-charting, I would have 8x equals -24, and then I would divide by 8 on both sides, and so I would have x equals -3. So that would give me my vertical asymptote, x equals -3. My horizontal asymptote would be the x's being divided. So you can't see that anymore, so let me not do that color. So we would be working on, let's see if I can do this. If I do that, there we go, kind of, that works. So this vertical asymptote would be from 4x divided by 8x. So my y value, whoops, wrong button. My y value would be, I'm going to write it down here. Y equals, and this would be 4x divided by 8x. If I put this in fraction form here. But as 4x divided by 8x, that would reduce pretty nicely to just 1/2. So I would have for my horizontal asymptote, y equals 1/2. And so if I was to go in and actually draw that, let's see here. So if I drew my vertical asymptote, I have x equals -3. And sure enough, there's my vertical asymptote. There's my vertical line. And yep, it looks like my lines, my branches of the hyperbola are approaching x equals -3. My horizontal asymptote, it says it's a half. So here's a half. So if I was to draw this in, and here's where you can really see it looks like I'm right about a half. So it kind of approaches here and it just approaches, but it never actually passes that, that horizontal asymptote. Oops, too far. There we go. That looks even better. So we can see it just approaches and kind of skims the line. So then, of course, finding our domain and range for these is really no different. So our domain for our hyperbola, for our rational function, it still would be the same as our domain that we did for our other form of the rational function. So we would still be doing our negative infinity to the vertical asymptote and then taking that vertical asymptote, splitting it, and dividing it into these two equal parts. So we're never actually equal to -3 on the denominator, but we approach -3 on the denominator. So then on our horizontal asymptote, we would be doing the exact same thing using the horizontal asymptote value. So we would have our negative infinity, and then to our horizontal asymptote, which is 1/2, and then picking up on the other side of our 1/2 and going off to positive infinity. So nothing too crazy there. Alrighty, so I'm just going to put that there. There's my fraction. That's how I came up with this handy dandy number there. That's where that came from. Okay. All right, so then let's do some graphing with this kind of function. So just do a quick example here. So if we wanted to graph this kind of rational function, if it wasn't already graphed for us, here we're going to do the exact same steps as before. We're going to figure out our vertical and our horizontal asymptote, which means then we'll also know our domain and range. And we're going to plot those, draw those on the graph, and then we're just going to use our graphing calculator to figure out all of the other numbers. So we want to have, thinking about this, if we were looking at our vertical asymptote, so vertical asymptote means we take the denominator and we just set it equal to 0. So first things first, if I had, I'll use green for this, 3x plus 6 equal to 0, then I could solve this by, there we go. I would subtract the 6, so I'd have 3x is equal to -6, and therefore my vertical asymptote would just be x equals -2. So nothing too terrible there. My horizontal asymptote, if I was to work on that one, that would be my my x's divided by each other. So I would end up with y equals, oops, that's not a y. Y equals, I'd have 9x divided by 3x. And so that would make this, if I wanted to have that as a vertical asymptote, that would make this just a horizontal asymptote, my bad. That would make that as just y equals 3. So nothing terrible. It's just a nice little division. There's an arrow. It's fine. It's all good. There we go. End style. So there's my asymptotes from there. If I wanted to go in and find my domain and range, my domain, of course, would be from negative infinity to -2. And then on the other side of it, I would end up with a -2 all the way up to positive infinity. For my range, I should see something along the lines of negative infinity. So we're kind of making predictions here. Negative infinity to 3. And then I should see it pick up on the other side. And I should have from 3 to positive infinity. There we go. So that's what we should see when we go ahead and graph this. So let's do this and see if it actually does what we said it was supposed to do. So we made some predictions and now we're going to check those predictions and make sure they're right. So we said our vertical asymptote should be at x equals -2. It's all right. There's an arrow. Technically, the asymptotes do go on forever, so no big deal there. Oops, that's the one. And then we said our horizontal asymptote should be y equals 3. So I should see something like this. So then to get these points that I want to have on my graph, I'm going to need to pick some numbers from the left and from the right of the vertical asymptote. So -3, -4, -5, anything from -3 out to -10 would work. And so then what I'll do is I'm going to go ahead and go to my calculator, and I'm going to hit my y equals button. I'll clear out what's in there. And now this time when we go to graph this, we want to say that, hey, the entire numerator, so I'm going to tell my calculator, everything on top is 9x minus 1. And that, so I'm going to use parentheses to make sure the calculator knows what's going on, because they're not very smart. They can calculate, but they're not smart. They can't interpret our questions for us. We have to tell it. So here's our equation. If I go ahead and graph it, I should see I have a graph that's going to be in kind of like the second quadrant area, and then we have one that's kind of in that fourth quadrant area. So split around our asymptotes. So we can tell our asymptote, we said one of them was going to be in x equals -2. So we should see this nice, if we look at and try to graph or visualize, there would be a line from -2. We said the other one we said was going to be y equals 3. And I could even graph that one because it's already y equals. So if I graphed y equals 3, I should see, yep, sure enough, there's my other asymptote. So it approaches, but it doesn't actually pass. So now I'm going to look at the table and find some points that are on either side of that asymptote. So we can see here, they're not nearly as friendly as they were before. None of them are going to come out as like super nice answers. So really it's kind of a matter of picking. So like I could do -8, which gives me about 4.1. I could do -5, like any numbers here would be fine. You could just pick the 2 or 3 to the left. I'm going to go ahead and type in a few of those and see what I come up with. So I'm just going to grab kind of 3, 4, 5, 6, 1, 2, 3, 4. Yeah, I'm going to grab those just because they're right there. So if I want to go ahead and start typing that in, I'm going to pick blue for my color this time. And I want to make sure that my computer does what I want it to do. So I said I'm going to start by picking, let's see here. I'm going to do, I have -3 and I get like 9.3 repeating. I had -4 and I got like 6.16 or 6.2-ish. I have -5, which is about 5.11. And I have -6, which is about 4.5 or 4.6. So they're just estimations here for us. When I look in the graph, so I'm going to go ahead and just write all my numbers in here really quick. On the other side of the asymptote, I could have -1, 0, 1, 2, 3, 4, all of those. So same thing, I'm just going to come over here and I'm going to look on my graph. Here's my asymptote. So I can see through the table that my asymptote vertical is -2. So everything beyond that are just going to be some numbers I'm going to kind of type in. So I'm just going to pick a few of those and work with them. So, so I have -1, -3.3, 0, -1.7 or -0.2, 1, and I have about 0.9, 2, and I have about 1.4. So I'm just going to type a bunch of those in really quick. So let's see here. I'm going to do -1, and I'm going to use, let's see here, -3.3. I'm going to do 0, and I'm going to use -1.7 or really -0.2. I'm going to do 1, which ends up being about +0.9. So we're just under the 1. And then 2, I'm going to use about 1.4 is the number that I see in my calculator. And so then again, just like we did before, I'm going to grab and color or plot these points. So I have -3, -9.3, so I'm like way up here, -4, and I'm at 6.2, so I'm like here, -5, and I'm at 5.1, so I'm like there, -6, 4.6. So we can kind of see the more points you put in there, the more you can see the curve as it's going about. On the other side, I've got -1, and I have -3.3, so I'm like here-ish, 0, and I have -0.2, so I'm just under the origin, 1, and I'm just under 1, so 1 and 0.9, and then 2 and 1.4. So again, we can kind of see how that is a symmetrical, or we can see that symmetry as it rotates or moves around that graph. So we're going to try to graph my branches here as best I can. This is me doing this with a mouse, so I'm feeling pretty good about that line. It's a little tough to do. And the same thing over here. I'm just going to kind of quickly, mostly what we're going to be looking at are your tables to make sure that everything matches up and that your graph kind of makes sense. So they don't have to be super beautiful like the computer does, but they just have to give us an idea that you know what you're dealing with. So you don't have to do any HAK, which is kind of nice. All right. So then the last thing we're going to look at, of course, we have a word problem. You guys didn't think you were going to get out of this without a word problem. We have the senior classes sponsoring a dinner. The cost of catering the dinner is $10 per person, plus there's a $20 delivery charge for all of the food. So that's actually not that bad of a delivery charge. I totally would expect it to be more than that. But it's, assuming that this is you're talking about your senior class, there's quite a few people. So there's a lot of food coming. So we want to know what's a model that gives the average cost per person for the dinner and the delivery charge. So when we think about how this would work, well, we know that the cost of the dinner is equal to, it's $10 per person. So if we say X is the number of people, we can say P, I'm going to use X, plus the $20 delivery charge. That's the total cost of the dinner. But what we want to know is what's the average cost of the dinner. And so what that means is that we're going to take this 10x plus 20 as the average, and we're going to divide that, all of that, per person. Oops, that's fine. I wasn't going to do that line, but it's okay. We're going to divide that by all of the people in the dinner party, all of the people that attend it. So each person would just be X. So there's our equation, 10x plus 20 over X. Remember, the X's do not divide out because this 10 and 20 are not, are part of the X value, part of that numerator value. So now it says graph the model and use it to estimate the number of people needed to lower the cost to $11 per person. So we can see here, if we think about our asymptotes, we've got an X on the bottom that's just going to be equal to 0. So we're going to have an asymptote at 0, and we're going to have an asymptote at, so I have a vertical asymptote at 0, and then I'm going to have a horizontal asymptote at 10, because I do 10x over just X, so I'm going to have a horizontal asymptote. So we definitely are not going to have a price go below $10 because it says that it's $10 per person plus the delivery charge. So it's going to be a little higher than that. So what we want to figure out is what are some numbers that would work for this, this equation, this problem. So I'm going to look at typing this into my calculator to start with. So 10x, so if I do parentheses, just like I kind of drew it out there, 10x plus 20 divided by per person, everybody kind of splits that, that delivery cost. So if I look at my graph, I've got this hyperbola on the left, that branch on the left, and then I don't really see anything on the right. And that's because this graph is going from 10 to 10. So we said that it's not going to go any lower than $10, so we need to change our window. So I'm going to hit the little button here that says window next to that table set. So I'm going to say, well, my X minimum, really it's not going to go below 10, but I'm going to put it at 0 so that it looks like the graph that's on our paper. Our max, our graph on our picture here has a graph that starts at 20. So I'm going to go with 20. And I'm going to keep my scale. That's just what is it counting by? It's counting by 1. So I'm going to keep that. For my Y's, I'm going to use 0 again. And then I'm going to use 20 just like it is on our picture. And same thing, I'm going to keep my scale counting at 1. So now if I go to graph this, that's kind of the same picture. And we can see we've got this nice line. If I was to even plot in my asymptote, not 20, 10. I have my horizontal asymptote at 10. I'll see that, yep, this line is going to approach, but it's never actually going to cross that $10 per person. So now I want to be able to actually plot those points on my graph. So I'm going to hit second and then table. And I'm going to find some nice numbers. Now, obviously, oh, that Y1. Let me get rid of that Y1. It's kind of a, it's like they're all 10. That doesn't make any sense. So we won't use any of these negative numbers because we can't have negative people. That would be weird. We can see here our first, if one person goes to the dinner, well, it's $10 for that one person plus a $20 delivery charge. So that's why it's going to cost them $30. If 2 people go to the dinner, each person will pay $10 and the $20 delivery. So that would give us $40, but then they're splitting it into 2 people. So it's splitting the cost by 2 people. So we end up with a $20 total for our person there, for our secondary person. So I'm going to go ahead and plot 220. So there's a point for me. And I'm just going to kind of keep going. I'm going to look at all my whole people, well, whole dollars anyways. So 4 people, it's going to cost $15. 1, 2, 3, 4. It's going to cost $15 when we split that up. And then if I look at, well, 5 people, it costs $14. Oops, right about there. So then it looks like I've got 10 people, it's going to cost $12. 6, 7, 8, 9, 10. It's going to cost $12. And I could keep going and see if I can ever. And sure enough, when I get all the way down to 20, we get $11 per person. So we could plot any of these other ones too, but it's just easier, I think. So when I get all the way down here to 20, it's going to cost $11. So we're going to kind of have this branch that sort of runs around like this. So there's our graph as we approach all of that. So there's our equation. So, oh, and it says graph the model usage to estimate the number of people needed to lower the cost to $11 per person. Oh, well, hey, we figured that out. We graphed it on the table. It was going to take 20 people to lower the cost to $11 per person. And again, that's because if I think about this formula, this pattern, it's $10 per person. There are 20 people plus a $20 delivery charge divided by those 20 people that are in the that are kind of splitting all the costs together. So 10 times 20, that'd be 200. Let me put this in parentheses. So that's 200 plus 20, which really is saying it's 220 divided by 20. And that's what gives us that $11 average. Move this up so you guys can actually read that. So then it says, describe what happens to the average cost per person as the number of people attending the dinner increases. So as we add more and more people, there's more and more people to split that $20 charge. So what's happening to their cost? Oh, well, it's pretty easy. Their cost goes down. That's it. So, and that's good because there's more people to split the funds, split the charge. So that's why it's going to go down because you don't have as much to pay per person. All right. And that's how we graph rational functions. It's pretty basic, hopefully. It's really just using your calculator and getting some of those asymptotes drawn in first. So, alrighty. Have a good day. I'll see you later.